Space, the final frontier. Today, we delve into the Goldilocks zone, a space region crucial in our quest for extraterrestrial life. Often referred to as the habitable zone, the Goldilocks zone is a region around a star where conditions might be just right, not too hot, not too cold, for liquid water to exist on the surface of a planet. This is no arbitrary definition. Liquid water is considered the elixir of life, the key ingredient in the recipe for life as we know it. Therefore, finding a planet in the Goldilocks zone of its star boosts the odds of discovering life beyond Earth. But remember, being in the Goldilocks zone doesn't guarantee the presence of life. It simply means that the conditions could be right. Now that we have an understanding of what the Goldilocks zone is, let's explore the factors that determine its boundaries. The Goldilocks zone isn't one size fits all. Various factors come into play in determining its boundaries. The first factor to consider is the star's luminosity, or its total energy output. This is important because the higher the luminosity, the further out the Goldilocks zone will be. On the other hand, a star with lower luminosity would have its habitable zone closer in. The second crucial factor is the planet's distance from the star. The closer a planet is to its star, the more energy it receives and the higher its temperature. Conversely, a planet that's too far away would receive insufficient energy, making it too cold for liquid water to exist. In this delicate balance, we find the Goldilocks zone, not too hot, not too cold, but just right for the existence of liquid water. With these factors, we can identify where liquid water might exist. But why is liquid water so important? Let's find out. Water is the elixir of life, at least as we know it. This isn't just a poetic expression, it's a scientific fact. For life as we understand it, liquid water is absolutely essential. But why is this so? Well, first off, water is a remarkable solvent capable of dissolving a wide variety of substances. This makes it an ideal medium for chemical reactions, many of which are fundamental to life itself. Whether it's facilitating the transport of nutrients in a cell or acting as a reactor in which complex biological processes take place, water is at the heart of it all. In our search for habitable environments beyond Earth, the presence of liquid water is a key indicator. It's a sign that a planet or moon might just have the right conditions for life to exist, or perhaps even thrive. Water is a fundamental ingredient for life, but the type of star also plays a crucial role in the habitability of a planet. Not all stars are created equal, and this diversity impacts their Goldilocks zones. Just as the personality of a star is defined by its size, mass, and temperature, so too is the habitable zone that surrounds it. To illustrate this, imagine a red dwarf star, smaller and cooler than our Sun. Its Goldilocks zone is much closer, meaning planets orbiting in this area would need to huddle close to bask in its warmth. However, being so near to the star could lead to other complications, like tidal locking, where one side of the planet is always facing the star, creating extreme temperature differences. On the other end of the spectrum, we have the massive and hot blue stars. Their Goldilocks zone is much farther out, providing a wider habitable area. But these stars burn out quickly, leaving a relatively short window for life to develop on any orbiting planets. In between, we find stars like our Sun, a yellow dwarf, offering a temperate Goldilocks zone at a comfortable distance. This allows for a stable climate and the potential for life, as we know on our very own Earth. So, the type and size of a star play a crucial role in defining where its Goldilocks zone lies and what conditions a planet within that zone might experience. Different stars, different zones. And within these zones, we find intriguing exoplanets. Beyond our solar system, exoplanets within their stars' Goldilocks zones captivate our curiosity. These are worlds orbiting other stars, located at a perfect distance where the conditions could be just right for life as we know it to exist. One such exoplanet of great interest is Proxima Centauri b, the closest known exoplanet to us, located in the habitable zone of the Proxima Centauri star. This world, while exposed to stellar winds far stronger than Earth's, could potentially hold liquid water on its surface under the right atmospheric conditions. Another fascinating find is Kepler 22b, the first confirmed exoplanet in the habitable zone of a Sun-like star. Although it's about 2.5 times the size of Earth, its moderate surface temperature could allow for the existence of liquid water. Then there's the TRAPPIST-1 system, a compact solar system that houses 7 Earth-sized planets, 3 of which lie within the star's habitable zone. The proximity of these planets to one another and their star suggests the possibility of life hopping from one planet to another. These discoveries, while remarkable, are just the tip of the iceberg. They contribute to our understanding of potentially habitable environments beyond our own world, and inspire us to further explore the vast, uncharted territories of space. From distant exoplanets to our neighboring planets, let's examine Mars and Venus as examples of Goldilocks zone variability. Mars and Venus, our neighboring planets, provide valuable insights into the variability of the Goldilocks zone. Let's take a journey to these celestial bodies. First, let's visit Mars. Mars is a tantalizing world that sits at the edge of our solar system's Goldilocks zone. It's a bit chilly, and its thin atmosphere can't retain much heat. This makes it a less than ideal candidate for liquid water and, by extension, life as we know it. Now let's swing by Venus. Venus is closer to the sun than Earth, and it's sweltering. Its thick atmosphere creates a runaway greenhouse effect, making it far too hot for liquid water to exist. These examples illustrate that being in the Goldilocks zone doesn't guarantee habitability. There's a delicate balance between too hot and too cold, too much atmosphere and too little. While Mars and Venus offer lessons, life on Earth provides its unique case studies in the form of extremophiles. Life finds a way, often in the most extreme environments. This is where astrobiology comes in, a field dedicated to the exploration of life beyond Earth. Astrobiologists study life in its myriad forms, including the fascinating group known as extremophiles. Extremophiles are organisms that thrive in conditions we humans consider harsh or even deadly. They exist in deep-sea vents, acidic lakes, Arctic ice, and even radioactive waste. These hardy life forms expand our understanding of what is considered habitable. If life can exist in such extreme environments on Earth, then why not on other planets or moons with similar harsh conditions? Extremophiles challenge our traditional notions of suitable for life and illustrate the incredible adaptability of life. They show us that life is not just about surviving in the Goldilocks zone, but it's about thriving where least expected. Life's adaptability on Earth opens up possibilities for habitable environments on moons. Moons are not just celestial ornaments. They could be hosts to life. Let's take a cosmic journey to the moons of planets within the Goldilocks zone. They're not just orbiting their planets, they're also in the habitable zone, potentially offering double the chance for life. Consider Europa, one of Jupiter's largest moons. Beneath its icy surface, there could be an ocean of liquid water twice the volume of all of Earth's oceans combined. And then there's Enceladus, a moon of Saturn. It's been found to have geysers erupting with water vapor, a strong indicator of a subsurface ocean. These moons could be life's hidden sanctuaries, providing necessary conditions for organisms to thrive. It's a tantalizing possibility that these moons could host life, challenging our Earth-centric view of habitability. From moons to planets, the stability of climate and atmospheric conditions plays a critical role in habitability. A stable climate and the right atmospheric conditions are the canvas for the painting of life. A planet's climate stability plays a pivotal role in maintaining conditions suitable for life. It's akin to a thermostat, keeping the temperature just right for life to thrive. Now let's consider the atmosphere. It's like a protective blanket, shielding the planet from harmful solar radiation and helping to regulate surface temperatures. It also plays a key role in the water cycle, which is vital for life as we know it. One of the most significant atmospheric factors is the greenhouse effect. This phenomenon, where certain gases trap heat in the atmosphere, is crucial to keep a planet warm enough to sustain life. However, if too intense, it can lead to a runaway greenhouse effect, making a planet too hot for life, much like Venus. As we've seen, the Goldilocks zone is not a static region. Stellar evolution impacts it significantly. Stars evolve, and with them, their Goldilocks zones. This cosmic dance plays out over millions, even billions of years. As stars age, they change in size, temperature, and luminosity. These changes affect the location and extent of their habitable zones. For instance, our own sun is slowly getting hotter. Over the next billion years, it will become so hot that Earth will no longer be in the sun's Goldilocks zone. This doesn't necessarily spell doom for all life. Just as life on Earth has adapted to various climatic changes, it's possible that life elsewhere could adapt to a shifting habitable zone. However, this does complicate our search for life. We can't just look for planets in the current habitable zones. We have to consider a star's past and future states as well. Stellar evolution impacts the search for life, but so do our technological advances. Our quest for understanding the universe is powered by technological advancements. The tools at our disposal today have dramatically improved our ability to study exoplanets and their atmospheres. Space missions like the Kepler Space Telescope have been instrumental in discovering thousands of exoplanets, some of which reside in their star's Goldilocks zone. Meanwhile, the Transiting Exoplanet Survey Satellite, or TESS, is currently scanning the skies for nearby exoplanets. Ground-based telescopes, too, have played a crucial role. The European Southern Observatory's Very Large Telescope, for instance, has been key in analyzing the atmospheres of these distant worlds. Innovative techniques such as transit photometry and radial velocity measurements have also enabled us to determine the size, mass, and potential habitability of these planets. As we look to the future, our exploration of the Goldilocks zone is only set to intensify. With each technological leap, we inch closer to answering one of humanity's most profound questions. Are we alone in the universe? The future is bright, and the search for life beyond Earth continues. As we look toward the horizon, there's an array of exciting missions and research initiatives on the docket, all aimed at identifying and characterizing planets within the habitable zones. The James Webb Space Telescope, for instance, is set to revolutionize our understanding of these zones, allowing us to probe the atmospheres of distant exoplanets like never before. NASA's Exoplanet Exploration Program, too, is poised to make significant strides in the hunt for alien worlds. With missions such as TESS and Kepler, we've already discovered over 4,000 exoplanets, and that number is only set to grow. These endeavors, and many more like them, hold the promise of future discoveries that could dramatically reshape our understanding of habitability. Perhaps we might even stumble upon that elusive second Earth. The search for life is a collective endeavor. Let's explore how you can get involved. The search for life beyond Earth is not just for scientists. Everyone can participate. The exploration of habitable zones, or Goldilocks zones, is a fascinating field that invites all curious minds. Educational outreach programs play a crucial role in this endeavor, aiming to spark interest and foster understanding about astrobiology. They help us comprehend the conditions necessary for life to exist, and why certain regions around stars, the Goldilocks zones, are the focal points of our search for extraterrestrial life. But it doesn't stop there. The rise of citizen science initiatives provides opportunities for anyone to contribute directly to this research. These initiatives welcome the public to analyze data, make observations, and even discover new planets within habitable zones. They're a testament to the idea that the pursuit of knowledge and the exploration of the universe is a collective effort. As we conclude, let's recap the key points about the Goldilocks zone. From the vast expanse of space, we zeroed in on the Goldilocks zone today. Remember, it's not just any region around a star, but the one where conditions are just right for liquid water to exist. The star's luminosity and the planet's distance play a crucial role in defining this zone. We've also learned why water is so important for life and how different stars can have different Goldilocks zones. We traveled to the exoplanets in these zones and even took a detour to Mars and Venus, our solar system's very own examples of Goldilocks zone variability. Our journey also introduced us to the field of astrobiology and how extremophiles on Earth can broaden our understanding of life's adaptability. We explored the potential of habitable environments on moons, the role of a planet's climate and atmosphere, and how stellar evolution impacts habitability. The Goldilocks zone, a space region where conditions might be just right for life as we know it. Our quest continues, and with each new discovery, we get one step closer to answering the age-old question: are we alone in the universe?